All right, the admission fee at an amusement park is $2.25 for children and $6.40 for adults. On a certain day, 310 people entered the park, and the admission fees collected totaled $1,154. How many children and how many adults were admitted? Well, let's find out. So the first thing we need on this one, and again, just going back on this, it didn't say you had to use the system, so if you used guess and test on this, that would work. Most of the time when I've seen guess and test on this, students would say something like, well, there's 310 people, right? So usually they'll split it in half, or about in half, right? They'd say maybe there's 150 adults, and then would that be 160 children? And then they would say, well, I know that's 310 people, but how much money would they bring in? And if it's not $1,154, then they start over, or they would adjust these numbers accordingly. Now that is a valid method, but of course we're in a systems module or unit on this one, so I'm going to proceed with the systems on this. And the first equation I'm going to write is based on this 310 people, right? And we do need to define the variables. For those of you that turned in the NBA reality check, it was good to see a lot of you guys define the variables. Just make sure you actually label your answers in the end. I know we define these right now, but it's good practice to start actually labeling your answers, especially for word problems like this. So it doesn't matter which you say is X or Y. Now for me, I'm going to say that X is going to be the children's tickets. I'll just say children. And then the Y I'll say is adults. And again, it doesn't matter which you say is which. You could have even have used C and A if you wanted to, but that's up to you guys, okay? So, but I'm in the habit of using X's and Y's, particularly because, well, we're used to seeing them, okay? Children, I think I spelled that right. All right. So just for the 310 people, right? You got the number of children that came into the park. You got the number of adults that came into the park. When you add those together, you should get that 310 people. So there's my first equation. That's good. And that equation is based on the people. The next equation is going to have to be based on the number or the amount of money that they brought in on this, which of course is $1,154. So whatever total we get needs to equal this. But let's look at the children first. Okay, how much money did they bring in from the children's tickets? Well, it says up here at the top that it was $2.25 for the children, right? So I would take $2.25, multiply it by the number of children that came in the park, and that would tell me how much money they brought in from the children's tickets. Now the adults' tickets, though, those are $6.40, so I would take the number of adults that came in, I'd multiply it by $6.40 and add those two together, which is going to equal the total amount of money they brought in, $1,154. All right, so this is our system of equations. And now we're ready to manipulate this one. And some of you guys, of course, and it is okay to get rid of the decimals on that. And, I put the 0 right there. You didn't have to, but I like to show it just so we know that it coordinates with the amount of money that the adults' tickets costed. But I can manipulate that first equation by simply multiplying it by the opposite of one of the other coefficients, right? So we have to determine right now, do we want to get rid of the X's or the Y's in this system? Which one do you guys want? All right, so if we eliminate the X's, that's children's tickets, right? I would say I'm going to multiply this top equation by 225. Now, not just 225 even, right? Because that just makes the coefficients the same. I need them to be opposites. So I'm going to multiply it by negative 225 and then distribute it into this equation. So that'd be negative 225x, also a negative 225y. But 310 times 225, negative 225. Yeah, I'm going to need my calculator for that. So negative 225 times 310, and I get negative 697.50. All right. Now again, I am comparing this to that second equation, the 225x plus $6.40 for adults, which was $1,154. So now that the coefficients of x are opposites, yeah, we're ready to eliminate them by simply adding the like terms. So that does zero out the x's just like we wanted. And then we got a negative 225 and positive 640 right there, plus 640. So that'd be $4.15 for the adults. And then negative 697.5 plus the 1,154. My calculator gives me 456.50. Alright, so from here, we only need to divide both sides by the $4.15. And that will tell us how many adults or adult tickets were sold at this amusement park. So $456.50 divided by $4.15 there. Oh, it comes out even. That's nice, 110. And again, why represent the adults in that? So whether you put adult tickets, I'm just going to put adults just because I'm lazy like that. But if you want to go the extra mile and say 110 adult tickets, that's fine. Well, I guess they didn't say tickets in that one. That's fine. Either way, adults. Well, now that we know that it's 110 adults, we can go to either one of the equations and solve for the number of children's tickets. And again, we saw that there's 310 people. So whether you use the equation at this point or not isn't really relevant. As long as you understand, you're going to take the 310, which was the total number of people that came into the park, subtract the adults, which was 110, and that gives you 200. And again, this would be children on that one. So even though it equals x, you don't have to write that it equals x. We know that it's children on that one. So just to check on this, right? It needs to equal 310 people, and 200 plus 110 that's a pretty easy calculation. It's 310 people, right? I'll use a different color on that. But what about the cost? Well, it's $2.25 for children, and there was 200. So 225 times 200 plus the $6, and it was 40 cents. Yep, for the adults. So 640 times 110 adults, and yeah, that comes out on my calculator as 1,154. So that confirms that this would be the number of children and adults that came into the park, as long as they collected $1,154 for 310 people at $2.25 per child and $6.40 per adult.